sometimes people kind of freak out when they see this thing here. And it's kind of funny looking, I'll admit. This 2 and the 3 over the log thing, like what does that mean? Well, look at it this way. What we're talking about is basically just log base 3 of y, but the whole thing is squared. Okay, and then the next one is just log base 3 of, gross, log base 3 of y to the 4th equals 12. So there's the equation that we're looking at here. Now, if you remember your properties of logarithms, specifically the power rule, that's going to come in handy for us here. If you remember the power rule, you'll know that this 4th power right here in the exponent can be rewritten the following way. I can bring that exponent down like so. I wrote the wrong base. I can rewrite that middle term like this. And then I have log base 3 of y squared plus 4 log base 3 of y. And you know, I'm going to get rid of the parentheses here just to try to make this more uniform looking. And then I'm going to subtract 12 over and get 0 on one side. You might be able to see the reason I'm doing this. Does this strike you as anything familiar? Maybe pause the video, take a look at it, and see what you can remember about quadratics. Okay, the technique I'm going to use here is called U-Substitution. And we've run into this a bunch of times. Basically, anytime you need to factor something, which is in quadratic form, and you don't really see how it's supposed to factor, U-substitution is the way to make that look easier. So here's what I'm going to do. I'm going to say U equals, and I'm going to pick the middle term. I always like picking the middle term here. I'm going to say U equals log base 3 of y. Okay, we'll make that substitution, and look what we get. It's going to be u squared plus 4 times u minus 12 equals 0. And now factoring is a breeze. We've done this a ton of times. This is just going to be u, let's see, plus 6 and u minus 2 equals 0. Well, now I'm going to use the zero product theorem to solve this one right here and this one right here. I'm going to set each of those equal to 0. So u plus 6 equals 0. That means u equals negative 6. And u minus 2 equals 0. That means u equals positive 2. Now, we're not done. We just found solutions for u. That's great, but we need solutions for y. That was the original variable. So I'm going to undo my u substitution at this point and say this. Log base 3 of y equals negative 6. And log base 3 of y equals 2. Okay, so that's nice. Now I have 2 log equations instead of the one I started with. It's like it had babies. But what we're going to find is that these are very, very easy to solve. Okay, we can do this in no time. If you remember the trick of turning logs into exponents, we take the base, raise it to that power over there, and we get the argument. So 3 to the negative 6th equals y. Hey, that's an answer for y. That's one of the solutions. And this one over here, 3 to the 2 power equals y. 3 to the 2 equals y. Now, if you want, you could say y equals 9, right? And whatever 3 to the negative 6 is, I don't know, something big, except as a fraction. But that's essentially the idea. The key here is recognizing that this equation we are giving is in quadratic form. It's not a quadratic, but it looks like one. So it allows us to do some factoring with U-substitution.